Hey folks, Paul Abernathy here. Welcome back to another episode here at Electrical Code Academy. Today's episode, we're going to talk a little bit about temperature limitations. And it's one of those topics that can get quite confusing for folks. They don't know, what do you use? Do you use the 60-degree ampacity column in 31016? Do you use the 75? When can you use the 90? And so we kind of want to break it down in this episode and kind of clear some of the myths that you might have when it comes to conductors and their limitations. So let's go on and get into it. Now, we're going to be working out of our Fast Tracks course. And of course, this is the 2023 edition of the Fast Tracks program. Again, if you're interested in really learning the National Electrical Code, check out this website right here. And just watch some of the demos to see what's in our program. It's not just for those that are trying to pass an exam. It's for electrical inspectors. It's for designers. It's for anybody who it really will make your job at maneuvering and understanding the NEC a little bit better. And ultimately, it's going to make your job a little easier because you're just going to know these things right off the top of your head. So again, it might be an exam prep course, but it is really a 30,000 foot view of the National Electrical Code. So we highly recommend it whether you're preparing for an exam or just want to get more knowledge of the NEC. Okay. All right, let's go into the lesson. All right, so what we're talking about is we're in 110.14C, and we're going to be talking about 110.14C1A, and then we're going to talk about 110.14C1B. But so C1A is dealing with 100 amperes or less, or conductor sizes that are 14 through 1 gauge. Okay, so generally, this would be a conductor that would be utilized under the 60 degrees C ampacity value. If we didn't know anything else, we would just say, okay, well, if it's 100 amps or less, or the conductor sizes of 14 through 1 gauge, then it's going to be 60 degrees C ampacities. And that's just point blank. But what we're going to learn is that that is not always the case. Now, there is obviously exception to every rule, like non-metallic sheath cable. Ultimately, at the end of the day, even though we can do adjustment and corrections from a higher ampacity value when it comes to NM cable, 334.80 is going to limit us to 60. Okay, that's a given. And that's controlled by Article 334. But generally, anywhere else, whether you're running individual conductors in a raceway or using MC cable, things like that, you're going to have to go and look at 110.14C1A or C1B at some point in your electrical career. So we want to make sure that we can kind of cover it and break it down for you. Okay, let's go work on the screen here. Now you see, as always in our courses, we have these call outs, these A, B, C, and D, and obviously this is going to translate to a graphic. So we'll kind of move back and forth to help you out a little bit. All right, let's read A first, and then we'll go look at it. What does A say? It says equipment terminal provisions for circuits rated 100 amperes or less, or marked 14 AWG through 1 AWG conductors are used only for conductors rated 60 degrees C, 140 degrees Fahrenheit, and that is told us in 110.14C1A. Okay. It says because the lowest temperature, the weakest link is 60 C, the ampacity of a conductor shall not exceed 70 amperes. So that is based on what we have in 310.16. Okay. So we can verify that and go look at that in the code, right? But the reason it says 60 amps here is because you would go down and look at our example, and our example is dealing with a 4-gauge THHN that is rated 90. But since this terminal is rated 60, even if this one's rated 75, the maximum is going to be 70. Why? Because of this weak link right here. Now, we're going to talk about this higher rated insulation and all that, but just let's keep it very basic right now. Think of the weak component. So in a conductor, you have 3 different aspects to it, right? You've got the middle span, which is the wire, and then, of course, you have the terminals at each end, how it's terminating. Each has a rating. Terminals have a rating, wire has a temperature rating, and then ultimately whatever you're terminating onto has a rating. okay, whether it's 75 degree C rated lugs or 60 degree or even 90. So everything has a rating. So think of it as in three pieces, if you will. And so that's important to remember, because you could have applications where you have an app or a device might be rated 60 degree C terminations. The breaker might be, lugs on a breaker might be 75, and the wire might even be 90. But the weakest component here is the termination onto the device, which was only 60. So thus you can't exceed the 60 degree. Even if your insulation is higher and the terminal on the supply end is rated higher, that's the weakest kind of link concept, okay? Now, B, which is pointing right here, where's B at? Right here. That's the terminal issue. It's telling you that a 4 AWG copper conductor with a temperature rating of 60 degrees C has an ampacity of 70 amperes. And again, that would be in table 31016. Oh, by the way, if you're a student in the Fast Tracks program, anytime you see these chevrons, you are going to stop and you're going to go to your code book and verify. Okay, so we're going to do the exact same thing. So we're going to go to the code book. And we're going to go here and we're going to go down to 31016 just to verify. And let's go right here. We'll blow this thing up for you. So you can't see all of it, but I'll move it around so you can see it. Let's see here. Yep, you're in the left column. Nope, you can't see the right side. So I'm going to get rid of this blow up and we'll do it this way. Okay, there you go. So there's 60. You see the 60. And we're going to go down to, and again, this is 4 gauge right here. And then you can see that it is 70, and that is under the 60. Okay? Make sense? All right. So we want to always make sure we're doing that. We never want to trust anything, you know, it's not that the Fast Tracks program is not accurate. It's just anything in life. If somebody tells you something and you question it, you want to make sure that you validate it. You don't just take it for gospel. Put your own eyes on it. It's so important to do that. And so when we give you these chevrons in the course, we're doing that because we expect you to pause yourself, grab your code book, double check us, and that way it kind of hammers home what we're talking about. Now, let's look at item C. So item C here is pointing to this 90 degree rated insulation, okay? So there's going to be something about that. So let's look at that. So C says a temperature rating of 60/75 C means that the terminal is suitable for 60 or 75, okay? So in our case here, it's telling me that it is good for what? 60 or 75. So we get to choose whichever it is we're doing. Now, obviously, to get more ampacity, if I have a choice for the terminal at the breaker, it's 60/75, but on the load side, the piece of equipment is rated 75, then I'm going to want to use the 75 because I'm going to get more ampacity out of it, right? In this case, under the 75 degree column, we're going to get 85 amps out of that same 4 conductor. That's huge, isn't it? So when we go look at the code, that same 4 conductor right here, you see here under the 75, just so you know, it's right here. Then we're going to get that same 4 is going to give us 85 amps. That's 15 more amperes out of the same conductor due to the fact of the rating of the insulation. Okay, now, of course, the insulation has to be at least 75, but in our case, it's THHN, so it's rated 90 for that application. Okay, so we're good to go there. Next, we want to look at D. Now, D is illustrating where we got D here. Okay, D is talking about a weak link, so it's going to be talk about an example here. So look, D, it says conductors' temperature limitations can be compared to the strength of a chain. A chain is only as strong as its weakest link. One prominent weak link for conductors is the termination connection point. The conductor ampacity shall not be higher than the lowest temperature rating of any connected terminal, conductor, or device. So that just serves to remind you that when you're looking at an installation, you need to look at the rating of the terminals, the rating conductors that you're using, and the rating of the end load, whatever the equipment that it's terminating onto. If all of those are 75, it really wouldn't matter if it is 100 amps or less, or 14 through 1 gauge. You would still be able to use the 75-degree ampacity, except for, like I said, things like non-metallic sheath cable, which, again, is going to ultimately lock you in the 60, even though you can do adjustment and corrections from the 90, but that's not part of this episode. But just remember, this is going to be very important when developing the weakest link theory of your ampacity of a conductor. Okay? All right, so the next one we're going to look at is E. Now, E is talking about the conductor, it seems. So it says, the ampacity of a 4 THHN copper conductor is 95 amps. Now, first thing that somebody will say to me is, wait a minute, we've been talking about 70, we've been talking about 85. How in the world do you get 95? Well, that's because that is the ampacity of the conductor. The conductor's got an insulation rating of 90. Now, I can use that 95 amps to adjust and correct for a number of current carrying conductors or ambient temperature that's other than 30 degrees Celsius, 86 degrees Fahrenheit. I can use that 95. But I still have my limitations per the terminals, which is 75. So I still can't exceed the 75. But all I'm doing is adjusting and correcting it to make sure that I still have a conductor that can handle the load. Even if it ends up being over the value under the 75, say the value of the 75 was 85, but after adjustment and correction from 95, I have a conductor there that they say is the ampacity is 88. Can I use that 88? No. I still can use the 85 though, because that's the value at 75. So all we did is make sure that we have a conductor that's still adequate for the values under the 75-degree column. Now, if I had done an adjustment for a number of current carrying conductors, let's say I had 8 current carrying conductors, let's say, and I start from the 95, if it had dropped me below the 85, then we would have a problem, right? Yeah, we'd have to look at our calculated load and see what it is in that scenario, and then we might have to up our conductor size. Okay, so it's really important to understand how adjustment and corrections work, and we have a video on that called Derating Demystified that's available over on our fasttrackstube.com. Make sure you go over there and just type in the search bar, type demystified, and it'll come up for you. But that is a really good video that kind of shows you how to do adjustments and corrections and gives you some examples of that. All right, next is F. F being, I guess, right here. So this is the terminal at the equipment end, let's just say. So it says a 4 AWG conductor with a temperature rating of 75 degrees C, right there, has an ampacity of 85. So we've already established that. We went and looked at 310.16 to establish that. So we get that. So one of the takeaways from this is if you were to take this conductor here and remove the terminations of the conductor, and you had a question, and then somebody said, what's the ampacity of a 4-gauge THHN? Well, that's easy. It's 95 amps. Well, then they say, well, can I use all of that 95 amps? Well, yeah, for adjustment and corrective purposes, but you're still going to be held to the weakest link theory, and that's going to ultimately be the terminations. So remember, as I said, there's 3 elements here. There's the termination at the supply end, there's a termination at the load end, and then there's the conductor in the middle. You could have 3 different temperature ratings. You could have a 60, a 90, and a 75 at the other end. Okay, kind of like this picture right here. And you got to remember that the 60 right here, that is the weakest component, so that's going to be the limiting factor. That's what we refer to as the weakest link. Let's see here, G. So G right here, now notice this says a maximum 85. That's what I just showed you earlier. It says equipment terminating provisions for circuits rated 100 amperes or less, right here, in case you're following along on the screen, or less, or marked 14 through 1 can be used for conductors up to their maximum ampacities if the equipment is listed and identified for use with such conductor. So that is the 110.14C1A3. It says the ampacity of this conductor now has an 85 ampere because the lowest temperature, the weakest link, is 75. So that is interesting. So this is what you do every day in the field and you don't realize you're doing it. You're running MC cable, for example, and you know that it's under 100 amperes, and somebody comes along and tells you that it's got to be limited to 60 degrees. But the 60-degree ampacity table, which is 70 amps if it was a 4-gauge, in the NEC. And that's when you have to be able to explain to them that, well, wait a minute, if the terminals are rated 75, and the conductor's insulation is at least 75 or greater, in this case it's 90, then I can use the ampacity of the 75, okay? And this will sometimes cause quite a bit of arguments about, well, what is the ampacity of the conductor? Well, the ampacity of the conductor is the ampacity of the conductor without the termination limitations. It's just the conductor. But because we have these limitations based on the lugging, that's what's going to limit us to 75 degrees C. Now, that's not to say that there isn't applications out there where the lugs might be 90 degree rated and the conductor's rated 90. And then could I use it at its full ampacity? Could I use it at the maximum ampacity for that conductor? Absolutely, I could. Absolutely. 95 amps. If everything is rated 90, no problem. It can run indefinitely forever and never have an issue. The problem is we always have to look at our terminations and see if that's our weakest component in the situation. And it's very rare to have a 90-degree lug on an actual device. I'm not saying it's impossible, but circuit breakers, things like that, typically are going to be 60/75. And it's just one of those things that you just got to get familiar with as you're working into the trade. All right. A little extra tidbit here. We'll just throw this one out at you. I'll read it to you. I know the script is very small, but it says, when using conductors with temperature ratings higher than those specified for terminations, that means using the 90-degree rated insulation, for example, the higher ampacity can be used for ampacity adjustment corrections or both. So 110.14c, for example, an adjustment factor of 80% must be applied to 4 AWG THHN copper conductors because there will be 4 current carrying conductors. Now, this is in accordance with 310.15C1, by the way, so we're just giving you an example. Certainly not to take the place of the derating demystified, but again, I'll just give you the example. So if you have 4 current carrying conductors, if you go look at 310.15C1, it'll tell you, well, you're going to have a multiplier, and you're going to have to multiply that by an 80%. All right? So we do that 4 current carrying conductors. So the connected load requires an overcurrent protection and conductor ampacity rating of at least 70 amperes. But the lowest temperature rated terminal is 60 degrees C. Okay? So it says a 70 ampere overcurrent protected device can be installed with 4 AWG THHN 90 degrees C copper conductors because the allowable ampacity after the adjustment factor has been applied is 76 amps. Now why? Because we're able to use the insulation rating of the conductor for those adjustments or those corrections. So we were able to use that 95, remember, that's what the conductor's rated at 90 degrees C, 95, and then we multiply that by 80%. So when we multiply that by 80% or 0.80, okay, got to convert it into a decimal, makes it easier to do the math, that equals 76 amps. Well, 76 amps is fine. It's still higher than 70, not a problem, no harm, no foul, right? So if using the higher ampacity before derating were not permissible, the maximum conductor ampacity would have been 56 amps. So see, look, if you couldn't use that 90, then I would have had to have done it from the 70, which is the 60-degree column, right? If I wasn't, because of the terminals, then I would have been screwed. Because at that point, 70 times 80% would have been 56 amps, and that's not going to work on a 70 amp overcurrent protected device, right? So that means you're not going to get as much out of the conductor as you expected. And if you already had a specific load you needed to achieve, okay, then again, we need to get at least 70 amps out of this example. That's not going to work. That means that 4 gauge is not going to be adequate, and I would have to increase in size, and I would simply go from a 4 probably up to, since 3 is kind of rare, I would probably have to gone up to a 2. I guess you can find 3, but I would have had to do the math over again and see if it's adequate to handle the 70 amps. Okay, that type of thing. So this is why it's so important, folks, to keep in mind when you're dealing with the terminals, the conductor's insulation, and the end terminals. Think of it as 3 separate pieces in this kind of weakest link theory. Hopefully that makes sense to you. Now, if you're dealing with over 100 amps, then you're just automatically going to go to the 75-degree column, right? Unless, of course, you're limited by things like 334.80 for non-metallic sheet cable, which is going to limit you to the 60. Even though it's going to do the same thing, it's going to let you use the 90 ampacity because the insulation on those conductors inside of an NM cable are rated for 90. But ultimately, at the end of the day, you still can't exceed the value in the 60-degree column, and you still got to make sure that you can handle the load after an adjustment or correction. If that confuses you, don't worry. We have a video called Derating Demystified. I encourage you to go searching it on the internet, search it on YouTube. It's probably still up there, but I know that it's over in our Fast Tracks tube. Okay, so there you go. In another episode, we'll probably talk about the over 100 amps, but it's pretty straightforward, folks. Same concepts here. You simply are going to start at your 75 degree. Okay, all right, folks, that's it for this lesson. Again, if you're interested in learning more about the National Electrical Code, do me a favor, check out this website, and you'll be surprised what all's there. We have a lot of blogs, a lot of educational blogs that can help you. So again, hopefully you'll check it out. Till next time, folks, stay safe. God bless.